Welcome to this TSConf 2020 workshop. My name is Pierre Poupin and I will walk you through typing Loopback 3. This workshop is not really about Loopback, it's really about learning TypeScript notions. So if you're not interested in Loopback, this can still be for you. So for starters, who am I? As I said, my name is Pierre Poupin. I'm a web and mobile developer working at BAM. So BAM is a French web and mobile agency. We are famous in France for being React Native experts. So if you're interested, check us out. You can also have a look at my GitHub if you're interested. There's some cool stuff there. So it's /PierrePo. Yeah. So what's the purpose of the workshop? So as I said, it's really not about Loopback. Loopback is more a pretext to work on TypeScript. So our goal is to go through advanced TypeScript notions. We also will experiment with TDD applied to typing. So TDD is test-driven development. So roughly it's about writing tests before implementation. And here we'll do it with types because we're going to write type tests, which is pretty interesting, I think. And we'll do all this through a concrete example of typing a library, which is Loopback. So now you may wonder what is Loopback and why did I choose to make a workshop on it? So Loopback is a Node.js framework allowing you to build servers. It will provide an API to allow you to easily expose REST routes and also work as an ORM to persist entities in your database. I just look back because, well, I had to do it on one of my projects. We had the Loopback in place, and when we migrated to TypeScript, there were no types, and we had to add them manually. And finally, I think it's an interesting exercise because it covers many TypeScript concepts. So I think it's nice to see them in a concrete real-world examples. So what will the exercise look like? There won't be any implementation. There will be only types and type tests. So we won't even install Loopback. We're just going to type it. We're just going to write type definitions. So to write the type tests, we're going to use TSD, which you can check out on the link I put on the slides. And yeah, that's everything you need to know. So how we're going to do it? So as I said, it will be a step-by-step exercise. I will stop before each step. Give you some hints on how to do it and remind you the requirements of the step. And then I will give you the solutions after a few seconds so that you can pause the video first and try to do it yourself. So to do so, you should clone the following repository that you can find the link on the slide. And between each step, I really recommend you to check out using the tags I made and discard all your changes so that we work on the same code base. Otherwise, we will diverge. And even if what you've done is better than my solution, well, it could be hard to catch up. So there are tags, by the way. So you have step n dash expected or solution. You can check out the tags using git log. You should clone the repository, go inside it, install the dependencies. I use yarn, but you can use npm. Check out to the first step and run the tests. So if I do it myself, yeah, run yarn, git checkout, step 1, expected, and you're ready to go. You run yarn tests to have a look. Oops. To have a look at the tests. And it should be red because I just wrote the tests for the first step, so you need to implement the type. So what's the project structure? We have an src source directory, which is empty actually, index.ts, but it doesn't do anything because we don't implement anything. And we also have typings directory. 2 files there for now. The one with the tests, which we won't touch because I wrote the test for you. They are the requirements, what we want to achieve. And you have the index d.ts where we have the types that we want to implement. So that's what you're going to modify. So through the exercise, we need to implement models, and I needed to invent a fake business. So I invented a fake car business, which is like really simple and really dumb actually. So don't think too much about it. It doesn't really make sense, but well, it's still better than class A, class B. So we have a user having a name and an age. It can have many vehicles, which have a license plate, which is a string, and it can have also many bookings, which only have an ID, which is a string. Now let's go through the Loopback API. So it's going to be like really like light because I don't want to cover all the Loopback API, which wouldn't be interesting. It's not the goal. So what do we have? So for a given business model, like a user or vehicle booking, we have 3 concepts. We have the model, the instance, and the entity. So let's go through them in detail. First, the entity. So basically, it's pure business representation of the data. So a user has a name and an age, and that's all we can find in the entity. We do not find additional methods, nothing. It's really pure JSON. It's an object that could be passed through an API, and yeah. So there's no loopback notion in the entity. Once we have the entity, we need to talk about the instance. The instance is actually a kind of wrapper around the entity. So now we are talking about loopback. This is a loopback object. It has methods to interact with the database. So that's the ORM part of loopback. So when I fetch a user, my user instance will have an update method, which loopback will use to update my user in the database and persist my changes. So that's why we call it an active record, because we have an instance having methods to persist in the database the object we're working on. Okay, and at last the model. So the model contains all the loopback static loopback methods. What I mean by that is that, for example, you can find all the users. You can or you can find one user. These methods will return instances, so loopback objects that we can manipulate further using the instance methods afterwards. And that's it about loopback methods. Well, there are many more, but I won't present them. And also, the model contains remote methods. So remote methods are actually the API routes of our server that we want to expose. For example, if I add a add vehicle remote method, then I can declare some stuff about this add vehicle method, and I can say it's a post, so that users or other consumers, other applications can call my server using post on this route, and then it will execute the remote method I attached. So let's sum this up with a diagram. It's not really UML. I just wanted something visual, but it was really hard to rigorously represent with the UML, so it's kind of hybrid. So we will have an instance of our loopback app. It will be a singleton, so one instance. It will contain the reference to all the models. So here I only drew the user, but there will be also a vehicle and booking. So I can access to my user model, which has the static methods find, find1, which allow me to get the user instances. And the user instances has the update method, and it contains all the user entity properties. So as I said, it's exactly the same for vehicle, same for booking. Of course, there are some abstract classes that I did not represent here for model, instance, vehicle, entity, sorry. But we'll work, we'll see this during the exercise. So let's get started. First step, let's implement a very simple find method. So really dumb, no parameter, nothing. To do so, we'll need to implement the type of the Loopback app, having a list of models. We'll need also the user model type, which will have the find method, which will not return an instance for now, but a user entity. It's really for the sake of simplicity. We will implement the user instance later on. And note that this is a promise, so it should be asynchronous. And we will have to implement the user entity type, which will have the name and the age properties. In the end, this test is returned, and well, after the step, once you've done the implementation, it should be green. So I'll give you some time. You can pause the video, try to do it, and I'll come back in a few seconds. So good luck. Okay, welcome back. Let's implement the type. So first, as you can see, we need the user entity interface. So let's declare it. The user entity has a name, which is a string, and an age, which is a number. We also will need the user model. So the user model has the find method that will allow you to return an array of users, or user entities, sorry. And now we need to add our model to the Loopback instance. So user is user model. And now if I run the tests, it should be green. Yes, all good. So let's go to the next step. So what do we expect in the next step? We simply want to add a second model, entity model, which will be the vehicle. So, well, it's quite simple, so you can get to it. You can pause the video, and I'll come back in a few seconds. Okay, welcome back. Let's jump into the solution. So it's quite simple actually. It's just we just need to add a really similar, two similar interfaces as the user interfaces. So vehicle entity contains all the business keys. So license plate. Oops. Sorry. Broken shift key. License plate and the vehicle model would be find again, but this time it's a promise returning vehicle entity instead of user entity, and we declare it here. Vehicle is vehicle model. And now if you run the tests, should be all good. But something is not really satisfying with this, with what you just did. The problem is that those two are really similar, and actually we'd like some kind of so as you can see, it's the same, but it returns a different it has a different return type, but otherwise it's really the same shape. And if you remember the UML diagram I showed, we could picture like a an abstract loopback model class that would be have a signature that everyone needs to that every model would have. Actually, there is a shared there are shared properties. So we could picture this in our case with a generic interface. So what is a generic in TypeScript? You can see it as a kind of as if you were calling a function in JavaScript on which you would give parameter. Well, a generic would be the same but applied to a type. So you would have a type parameter, and this type parameter you could use it inside your interface. So if I say that my loopback model takes an entity parameter, and that this loopback model has a find method that returns an array of this entity. Well, now if I make my two models inherit from this generic interface, and I give the proper parameter, then I will have something strictly equivalent, but it will be refactored. Extends user entity. As you can see, the test should still pass, but this time we have a refactored generic class interface. Sorry. Okay, let's move on to the next step. So next step, what are we expecting? This time we want to implement the loopback filters. So loopback filters will allow you to fetch data according to certain constraints. Like for example, we could say that we want to find all the users being of age exactly 20. So that's how it would look like. It's a find accept an object that has a where key in which you have keys that correspond to your object keys, entities keys, having the same type. Like age should not be a string, it's a number. So yeah, each key should have the proper type corresponding to the entity. And also the key shouldn't be inside the entity's keys. It should be like blah blah does not exist in the user entity, so it's an error. So to achieve this, as you can see, it's age that is a number. As you can see, it's a part of the user entity interface. So what you could use is the partial of t utility type. So when you say that A is some object, if B is partial of A, then B will become will be A, but with optional keys, which we can. So as you can see, we can use it to represent a partial of user entity. So if now that you know that, you could. Well, I'll leave you to it. I'll come back in a few seconds with the solution. Okay, let's figure out the solution. So we want a filter to our find method that looks kind of like this. So a where object, an object with a where key that has some shape. So let's add a filter parameter that is a where object, an object that has a where key that is something. Let's see what the tests say. All right, so line 13, we have a first problem. So yeah, now we put a mandatory parameter, but we still want to be able to call find without anything. So it's simple. We can just put this as an optional parameter. So to do so, we can use the integration mark in TypeScript. Then we have. So we should have. Oops, I didn't say. We should have one less error. We still have two other errors. So this here should be an error, but it's not, because we just said that where could be anything. So yes, this is anything, so it works, but we want it to not work. So what we can do here, so as I said, this is similar to user entity, right? So we could naively put user entity here, so entity. But this is not true because it would force us to put all the keys every time, which we do not want. So as I said earlier, before jumping to the solution, I told you could use partial. So that's a good use case for partial, because here it says that it matches our object, but we don't have to put all the keys. So if we do not put name, then yes, it works anyway. It still works. So if we run the tests, it should be all green. Yeah. So we have a working solution. I would still like to refactor a little bit, just take out some types, because it would be useful later on. But I'm really anticipating it could be fine like this. So let's add first a new interface that's the query, the filter, query filter, sorry. This would contain the where key. That is the partial of our entity. So I need to declare the parameter. So partial of the entity, and we could use it here. Query filter of the entity, and then we could take it even further by taking out this to a where clause. So if we add a new interface, where clause, that also takes a parameter which is the entity, and we say that this is a partial of the entity that has nothing more, so empty body, empty keys. It should work, but it doesn't. So, which is perfectly normal actually. So why doesn't it work? So if you read this error, oops, sorry. TypeScript says that you cannot have an interface that extends properties that are not statically described. So what does TypeScript say that? So if you look at the implementation of partial, you can see that it's like computed properties, which is not compatible with having an interface. So we cannot. By the way, I'll come back to this syntax later because we'll use it for further steps. So we cannot have an interface here, which means we need to use a type. So here we should do it like this. So it's almost the same actually. Interfaces and types can be used in a very similar ways. So usually you don't even notice that it's different. So here we can use our new type alias, and then, oops, and the test should still pass. All right. So we just passed the test for step 3. So let's get to the next step. The next step would be nested filters. So what we want now is to have more operations on our fields. For example, I could say that I want to find a user who are not 20 years old. So I could use a not equal 20. So as you can see, it's one object further. Like age is not a number anymore. It's an object that contains other stuff, which will have the number at some point. Here it's below the neck and egg key. So I'll leave you to it. Oops, sorry. Partial won't be enough anymore. You need map types. So here is the documentation, but I can explain it to you roughly. So what we had now was a partial of user. So this would be a partial of user because it's only the age key. But now we want something different. This is not a partial anymore because this is not a number. But in user, age is a number, but here it's not. So what we could do is, so if we use this syntax, I say type B has this, so k in key of A, I'm here saying that B has the keys of A actually, and for each key, the type of my key is actually the same as A under this key. So using this syntax, B is strictly equivalent to A. But the difference is I can remanipulate my keys. So I could say that C is an object that has all the keys of A, that I make optional by the way, because I can. So C has all the keys of A, but I'm saying that each value under these keys are not directly the type of A of K, but an object wrapping this. So this is exactly what we would need for our deeper filter. So I'll leave you to it, and let's come back. I'll come back to you in a few seconds to show you a solution. Okay, let's go to a solution I propose. So we want to keep something similar to what we had before, but now the type of our field is not simply the type of the field, it can be a more complex object. So first, before starting to fill this requirement, let's run the tests and see which ones are failing. So line 58, which is normal, it's a new requirement. So first we want to, we will, so as I said, we'll have to use a map type to do this. So let's first rewrite this partial using a map type, which will be equivalent actually. If you remember, if we see the implementation of partial, we already have the solution of what I want to write, but let's write it again. So my where clause is an object. This object has properties that will be in the key of which the keys will be the same as the ones of the entity. And for each key that I name field, the type of the value under this key will be actually the same as entity under the same key. So this is equivalent to having entity, the entity, and now we want partial of the entity. So it's the same, we just need to add the fact that each key is not mandatory, but optional. So this should be strictly equivalent to what we had before, so only one failing test. Yeah. So that's one step forward. Now we want our key to have the value, the type value, either number or not equal of number. Oops, sorry, I cannot click. That's a little buggy. Okay. Somehow it's okay. I could not select here. So it's actually quite simple here. So this means age can be of type number, and we can say that it can be of type number, or it could be an ec of type number, and that's it. That should work. Now we want to, well, we need to make this a little clearer. So let's add a new type to take this out, because it's not really readable and we'll need to add more. So let's say we have a new where query argument, which would be which will accept something. And we want to refactor this whole thing. we want to pass only one argument. So actually this will be our argument, the field type. Oops, sorry, the field type. So let's declare this one, key field type. So now here we're going to use, the where query argument using the entity of field. Field. And this should still work. Oh, sorry. Yeah, tests are still passing. And let's add one last thing. Let's put an interface for this one because we can not equal query argument, which also accepts a field type and is only actually not equal of the field type. And here we can use it the field type. Sorry, it's not really visible. Yeah, and this should work, and it's more readable, I think. All right. So that's our solution: a map type and an object in front of it. Okay, let's go to the next step. But first, so I will check out to the next step, expected of step 5. So as you can see, there have been some changes. I did some refactoring that I won't show because it's quite pointless to show this. But I mean to tell you, so that you're not lost, I splitted the entities and the queries into different files because they would get bigger, and it's like the index started to get bloated. So yeah. So now let's get to step 5, the requirement. What we want now is we simply want another filter, which would be an include. That could be that has to be an array which contains the type of the field. So this basically means I want to find users that are age either 20 or 10. So it's quite simple actually. So yeah, we can get to it and come back in a few seconds. Okay, welcome back. So let's do this quickly. How do I add a new filter? Well, it's quite simple. I can take my existing not equal filter, duplicate it, and it becomes a include filter. And instead of an ECK key, it becomes an include key. And as you could see, this should be an array. So let's make this an array. And now just add it to our existing queries, and that's it. That should work. Let's run the tests. Yes, all good. Let's jump to the next step. So next step will be to add instance methods. So first I need to remind you what is the difference between an entity and an instance. So we've been using only entities until now. What does entity mean? It represents only raw data. So it's pure JSON, no functions, nothing. It's like not dependent of Loopback at all. It's just a model of data. So it's pure business data. Now, what we want to add as a concept is the instances. So what is an instance? It's an entity, but with some additional methods that Loopback provides. So in this, there are standard ORM methods. So for example, if I use user.find1, it returns an instance actually. And on this instance, I can call the method update so that I can manipulate my the user that I just got back and update it in the database directly. So Loopback will do the database manipulation for me. All right. Now that you know what an instance is, let's implement it. So actually, we've been doing a shortcut until now. We said that find returned an entity, but this is not correct. It should return an instance actually. So I changed this in the requirements, in the previous requirements. And now let's add new requirements. So actual instance methods. So now when I call user find1, I want to have an instance. And on this instance, I want to have an update method that will take something that has the shape of a user so that I can update the properties of my user. So of course, you don't have to provide all the properties. So you know what to use in this case. All right, I'll leave you to it. And yeah, please note that you need to add a new interface, the instance interface. Okay, I'll leave you to it and I'll come back in a few seconds. Okay, let's implement the instance types. So, first thing that we should do is, if you remember the UML, we kind of had inheritance between each instance, user instance, vehicle instance, booking instance. They all had like common properties like the update. So we should do the same as the loopback model here that was generic. We should do an interface like this. Loopback instance, which should accept an entity as well because it will have all the properties of an entity. So it should extend this. It should extend this entity, and then have the find method. But we'll see about that later. So first problem. Same problem as before, we cannot extend something that we don't statically know. So it cannot be an interface, it has to be a type. It has to be a type. Oops, sorry. Now it should work. Well, we haven't done anything yet, so let's build now. So the first error, let's build the vehicle instance and user instance interfaces. So let's build the user instance. It should extend loopback instance of user entity. Same with vehicle. User vehicle. Okay. Now we should have one less error because now we do have user instance and user entity and vehicle instance. So now it says that we lack the find1 method, so let's add it here. It's the same as find, but it only returns one entity. It should be one less error. Now it says that the update property does not exist. So let's add it. Since we have a type, if we want to add more keys, we need to use the intersection operator. So let's add the update function, which will have any data for now, and it returns void. Let's see how it looks like now. So now we have, so let's start with the first error. It says that here user should be an instance, but it's not, it's an entity because we still have entity here. So we should build a loopback instance out of this entity. Instance. Let's see what happens now. So, interesting. it says that user instance is not identical to argument type loopback instance of user entity. So here we have a user instance, but this is actually loopback instance of user entity. And you're gonna say, but it's the same, right? Well, not really. If you use an interface that extends something else, then it's kind of a new type, or it's a new interface. So even if it extends the same thing, it's not equivalent in TypeScript. It's not the same. So we need actually to have a type here as well. So if our type references the same thing as the other type, then it will work. So let's add a type here. Now we should not have these errors anymore. And there's one last error. It's this one. So we should have an error here in the update argument because this is not the good type. So why do we have this? Obviously it's because we put any here. Oops. So it should not be any, of course, it should be a partial. Oops. It's like the data should be a partial object of the entity, because we can put either only the age or both, age and name. Now, what do we have? No errors. So that's it for the instances. Let's get to the next requirement. So now we'd like to introduce the relations in our models. So what are relations? Well, it's quite self-explanatory actually. Our user entity can be related to many vehicles. So what we would like to have is a property in our user with vehicles that allows you to access our vehicles. So let's get to it, and we'll get back in a few minutes. Okay, welcome back. Let's add this simple relation. So it's actually super simple. Just need to add a vehicle's key and a user entity, which points to an array of vehicle entities. That's it. It's really simple for now, and of course we'll improve this. Our next step towards relations is to add the include filter. So first, it will be naive in the sense that you won't need to, it can be any string. And what is the include filter? It's the filter in your find and find one methods that allow you to get the entities when you ask loopback to get a user. If you do not include this, then user.vehicles is empty. So, well, let's add some types for this. All right, and should have been quite simple. Like the previous step, this is only about adding a key, a simple key to some object. So here we're working on the filter of our find. Oops, sorry. So we just want to add an include key to this query filter. So let's add include, and since it's naive, we can put any string for now. So let's see the tests, and it's red. It's red because we said that when we have a filter, it needs to have a where key and an include key, which is not true actually. We can have only one of them, or neither of them actually. So we simply have to make them optional, as we have done earlier. And this should be green. Yeah. So let's move on to the next step. So we are going to improve this include filter a little bit. Now we want to only have keys of the entity. So include blah 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 should not work. It should only be include of vehicles. To do so, you will need a new operator. I think you can figure it out yourself. It's quite intuitive. And you can find the info online. Alright, good luck. See you in a few seconds. Okay, welcome back to discover what this secret operator is. So you probably found it online, but I will still explain it to you. So if I want, so my goal here is to say that I want only the keys of my user entity as a valid relation, like any key for now. It's fine. So to do that, you can use the key of operator. So if I declare type my keys equals key of user entity, well, if you have a look at it, it's age, name, and vehicles. So we simply have to use this operator on our query here. Just say that our include is key of the entity, and that should do the trick. Let's run the tests, and it's all green. Next step, it's becoming a little trickier. So now we want to improve our include a little more. So as you could see here, I could include the name as if it was a relation, but it's not. It's simply a property. With this new step, I'd like you to only be make Loopback being only able to include relations. So my hint for that is that you need to be able to reference the keys of your entity and the keys of the relations of your entity separately. There are no new concepts. It's just refactoring and refactoring a little bit and then adding parameters. So I'll leave you to it, and let's catch up in a few seconds. Okay, welcome back. I hope you managed to do it. Let's see the solution I propose. So what we want to do ultimately, sorry, this, yeah, my click doesn't work well. Okay, what we want to do ultimately is to forbid keys that are not relations. So name is not a relation, so we should not allow it. So you can imagine that here, well, we know that this is wrong. Include key of T entity, this is not correct. It means we should have something like a new thing representing the relations of our entity, and only the relations. So let's add this generic parameter. So where is our query filter called? So that we adjust it. So it's in here. So it means that here we need an additional parameter as well. The entity relations. Yeah, we need this information. Okay. Which means we probably need to declare it here as well. And yeah. So no error, but still Loopback model, this is, we added a parameter, so we need to, oops, sorry. So we need to propagate this. So Loopback model, it means here we need a new thing. So let's add an interface, user relations, which contains, well, the relations of the user model. Like this, and let's do the same for a vehicle. Entity relation, vehicle relations, and vehicle relations. So if I run the tests, what happens? Oops. So line 100 says that vehicle entity is not identical to type any, which means that it has to be an error because vehicles does not exist on loopback instance of user entity. And if we go and have a look, it's true that a loopback instance is a join between the entity keys, the entity object, and on which we add the update method. But since that our entity object is now only this and not the relations, then it's normal that we don't have the vehicles key, which simply means that we need to add the relations here and join them with the rest. So of course this is naive and it will evolve. For now we put all the relations. So here where we call the loopback instance, we need to add the relations here as well, and we use the loopback instance here as well, so we need to put user relations here as well. Vehicle relation here. Okay. Let's run the tests and everything is working. So that's it for this step. Let's move on to the next one. Oops, sorry. Let's move on to step 11. So now we want accurate relations, which means that I don't want to include all the relations every time. I just want to have the relations that that I asked in my filter. So this is quite tricky and it needs 5 new concepts. Yeah, the solution I found is quite complex and it's a little hard. So let me suggest you that I will present the new concepts and explain to you how you should use them to achieve the results. But if you don't manage to do it, I think it's normal because it's quite tricky. So the first concept we need are the generic constraints. I will need the playground. So the generic constraints, I will give you an example. Let's say you implement the identity function. So x and returns x. Now let's use our function on a string a and on a number 1. So if I have a look now, it doesn't work because I did not type anything. So result 1 is any, result 2 is any. So what I want to do here, what I could naively do if I did not know about generics, I could say that this is either a string or a number, and it returns either a string or a number. But if I do this, then I lose. Oh, sorry, I called f. Well, still the same. It returned any, so it doesn't change much. Identity. Okay. Now I see that it's either a string or number, but I know that this should be a string, right? We know that, it's obvious. I mean, x is x. So this is not satisfying. This is not a good solution. So what we could do is we could add a generic parameter. If we add generic, so this should be the proper syntax, but because of JSX it doesn't really work, so I need to add a comma here. So now it works. So I add a generic here that says let's declare the type t. If x is of type t, then the return type is of type t. So if x is of type string, then return value is string. Oops. Same for the number. So that's cool, it works, but imagine I just want my identity function to work for string and numbers. well, this does not work anymore because this could be anything. And here, yeah, it works. So that's when generic constraints come in. So what I can say here is that t is either of type string or number, so it depends. And in that case, it will fail for an object. So that was generic constraints. Now let's talk about type argument default values. So imagine I have an interface. Yeah, I think you will see when to use this in our exercise. Sorry, it will be useful when you want to say that your generic type has the keys, is among the keys of some object, because later on you want to access to the keys of your object, and if your type does not match the keys, then TypeScript won't be happy. So I don't know, it's a little vague for now, but once you do the exercise you will understand, and I will explain more during the solution. So now let's go for type argument default values. Imagine I have an interface that has a function. My function is generic type t and returns t. So I don't know about it. Well, let's use my function. So to do that, I'll do a fake function where my parameter a is of type my interface. So if I use my function, oops, sorry. If I use my function, result is of type unknown because TypeScript cannot infer what t is. So for now, it's unknown. So imagine here I could provide a type as an argument, and here TypeScript knows it's a number because I told him so. But imagine I want this to work for anything. So I want it to work for number, but also want it to work for I don't know, strings. But I don't want to mention every time that this is number, this is a string, and I want it to be a number by default. Well, in that case, oops, I could say that. So I could say that this is a number by default. So it can be anything, but by default it would be a number. So if I have a look here, it's a number by default, and it still works with a string. I need to put any, otherwise the syntax doesn't work, but it's equivalent because if you don't mention anything, then t is, yeah, any. Okay, so that was type argument default values. Let's go for the pick utility type. By the way, how you will use this for the exercise. Actually, it will allow you to mention that by default you don't you don't want any relation by default. So if you don't provide any relation in your find function, then there is no relation. So that's basically the use case in our exercise. Okay, let's go for pick of the pick utility type. So imagine I have interface Toto, which has a, which is string, b, which is number. Well, it's quite simple. If I have my type hello, which is pick of Toto of a, then hello is of type string. So basically, pick allows me to get the type under a key of a given interface. So in our case, it will allow us, of course, to fetch the proper relation in our relation interface. Next, so the conditional types. What is this and how are we going to use them? So imagine you have an interface, my interface. It has a function, sorry, yeah. it has a function that returns something now. Imagine it has a generic. So for now, let's say the generic it returns itself. Now let's say that it's a little more complex than that. My generic can be a number or a string. And I want my function to return something different. I don't want it to return number if it's number and a string if it's a string. So that was the identity. I want something a little more complex. I want my function to return, like for example, a symbol. If t is of type string, and return a number if t is of type number. So what I can do for that is, if t is of type string, then it returns a symbol, and if it's otherwise, it returns a number. So if you have a look at this, a that's f string, it should be what happens here? Sorry, I don't need the argument here. Well, if it's a string, then yeah, result is a symbol. And if I give a number, then res is of type number. So how are we going to use this? It will be useful to pick our relation, and if we find the relation, then we keep the relation, and if we don't find the relation, then we will want an empty object, because we're going to use this as an intersection. So I know it's a little vague. If you do the exercise, I think you will get what I mean. Just know that I think you really need this. Last concept. You will also need type overloads. So what is a type overload? Imagine I have an interface that has a function that takes an argument, type string. Imagine I want my function to have a different return type according to the different arguments I give. So actually I can, if I do this, I implement exactly the same type as I had before, which is if x is a string. Well, almost, I mean, it's not the same types, but well, it's equivalent. If x is of type string, then I will return string, and if x will be of type number, then the return type will be a number. And it's exactly the same as what I did before with the conditional types. Why you should need this? Yeah, it's the same in our case, but I mean, it's more expressive this way. You will need this to overload the find function, so that you can have find without any inclusion and find with one inclusion. And well, that's it. I know that's a lot. I hope it will help you. If it doesn't, I'm pretty sure that once you see the solution that I will present, it will all become clear. And well, I should wish you good luck. And I will come back with the solution in a few seconds. Okay, I hope you managed to do something. If you didn't, it's okay. We'll have a look at the solution I propose. So, what we want to achieve is we do not want all the relations to be present all the time. So here, when we get a user without the vehicles, we don't want this to be defined. So if we have a look at our types, it's probably, we know that it's probably here that we should not be getting everything, right? So since we are working with one relation, we know that we will have to be picking something, like one thing from this object. So let's start this way. Pick. We want to ping something. some relation. I call it R. So we need to declare R because otherwise it doesn't make sense. So R, there is an error. What does TypeScript say? TypeScript says that R has to satisfy the constraint key of entity relations. So here, that's when the generic constraint come in. R has to extend key of the entity relations. So it makes perfect sense because if you want to access a key of entity this object, well, R has to be a key of this object. So, well, it raises new errors because the back instance now expects a new parameter. So let's add it here. So here it's not defined as well, so let's add it. Actually, it would be parameter here, and should always have the constraint. Same here, or instance key of the entity relations. Oops, that's it. So all good. So if we run the tests, what happened? What happens? Sorry. Yeah, I changed the back instance here, but it has to be changed. Well, here as well. R. Oh, sorry. So I need to add parameter R here. So I need to add it here. Extends key of user entity with relations. And same here. R extends key of vehicle entity with relations. Should be better. Now let's see what happens. Okay. Now our tests. So we have no TypeScript error in our files, definition files, but we do have many in our tests. So first error, line 17. Here it says that, well, user instance now need a parameter because, yeah, I just added something that makes me have to specify a relation. So actually this type here represents the user with the vehicles relation. But I do not want to do this. Actually, I would expect something like this, so like the user instance with no relation. So, well, let's implement this. So what we're going to do is we're going to add a default value that is null to represent an entity without any relation. So we need to implement two things: the default value and the fact that we can add null. So let's go back to the back instance. Well, let's go back to here where we the first time where we want to add our null constraint. So it means that now it's a key of user entity with relations or null, and it should be null by default. All right, same here. Oh, null and null by default. Is there a problem? Okay. So as you can see, I don't know why do I have an error here and not here? I don't know. I think it will be solved by the following that we're going to do. So here it should be now this or null, but it raises an issue. So I don't know why TypeScript doesn't say it. I think if I run the test, maybe it will say something. But yeah, R does not satisfy the constraint key of entity relations. So it means that I cannot pick a key of this object if this is null. It doesn't make sense. So what we can do is we could use a conditional type. We could say that if R is a key of entity relations, then pick the proper thing, and if it's not, then pick the, like, return the empty object, the neutral object for the intersection. So if R extends key of entity relations, then pick this, otherwise take the empty object. So now it should not complain anymore. Yes. So what's the problem now? So somehow this user always says that there's a vehicle, because it's, if we have a look at the find, it always handles relations. So I don't know why how it like inferred that it should be vehicles, the relation, but well. So the problem is we don't handle the no relations case. So let's overload this so that we have two cases. The case where we have relations and the case where we don't. So, oh, sorry, I completely forgot. I forgot to talk about the includes here, because somehow I want to get this information back from include. I would have been expecting for it to not work, but anyway. So here we're going, well, let's do it later. We'll have two cases. The case with relations is the case where we don't have any. So let's add an overload, as I said. So case with relation would be something like this. Without relations would be like this, and with relations would be something like this. And we'll need a different variable actually. Query filter and query filter with relations. So we'll need to add something new here. So this is the query filter, and we should add query filter with relations, which should be this, and extends query filter to the entity. Oops. This one should not have anything and should not have any relation. So yeah, autofix. So what happens now? It should still not work because we still didn't get the information of what inclusion we made. So here user still has vehicles. I think it's TypeScript inferred it from the, well, this thing here. Anyway, we should specify, we should have a way to get back this information of what, sorry, here, what key we are getting for the inclusion. So it has to be a generic type here. So here we take, we have to declare this new type, and it should have the constraint of being the keys in the keys of the relations. So if we do this and then we add it here, I think it should work, because TypeScript will infer from the call here, sorry, here when we call it with include, TypeScript will infer that, sorry, we infer that the R here is vehicle, and we pass it back here to our loopback instance. If I run the test, I think it should be all green. Oh, okay, I forgot something. So 17. So it still says that users have vehicles. Did I do something wrong? What did I do? Huh, there's an error here. Still. What? What's the problem? Ah. I know. Here there's no relations, so there should not be any generic parameter declared. And now, I forgot to add a default parameter here. So I think it should all work now. Yeah. Okay. Well, since it was quite complex, I hope you followed it all. I hope I'm not too fast, and I hope you got my way of thinking. If it applies to you, and if it makes sense. Let's go to the next step. We're going to want to implement the multiple relations. So actually it won't be too complex. We have most of the relation logic in place. So you just need to add more stuff, but we have all the concepts already. So, okay, let's get to it. Come back in a few seconds. Okay, let's get back to it. So, for the multiple relations, what we're going to start with is adding the new booking model. So it's quite simple. It's just it's really similar to the other models. It just has an ID and that's it. So simple research like this should allow us to create a new model. And here, instead of license plate, it's an ID. Let's add also the relation for the user, so the user can have many bookings. And okay, the booking model is ready. Now we want to have our loopback instance be able to have multiple relations. So let's add more. Let's add more generic parameters. So we can add R2 here and here. All right. So now it accepts more relations, and also we should have our user instance accept more relations because it uses loopback instance. So user instance should declare another parameter and pass them both to loopback instance. All right. Now the last thing we need to do is to get back the information of what relations we want to include from our filter. To do so, well, we'll have to add a new a new overload. So it will have another generic parameter. It will pass them both to the instance, and we will need a new query filter with relation type. So actually we will name it now query filter with two relations. Let's do the same with find one. Okay, copy and paste this, copy and paste this, find one. Let's reformat. Okay, nothing to reformat. And let's go and define the two relations query filter. So it's really a copy paste where we add a new generic type, R2, and it includes an array of R and R2. And let's change the name. With two relations. Okay, let's see what the tests say now. Oops, I forgot to import query filter with two relations apparently. What the fix. No. Did I do a typo? Okay. Let's run the tests again. All right. Fake identity is not identical to argument type any. Line 120. So when I find one, okay. I did not include this case with a single relation that is a single tuple with only one, an array with only one element. So let's add this. Run the tests again. Right. 130. What does it say? So booking entity is not any. So I guess this one did not get the information that we have booking. So what could have happened? So what you can do is control click and find one, see that it really goes to the proper overload. I see. So we do have the two parameters here, we do pass them here, but I forgot to pass the second parameter here. And well, something I had done here, so it should be fine. Okay, see how it's important to use the control click even on overloads. It really tells you which one it's using. Well, that's it. Looks like it works. So let's get to the next step. Next step will be remote methods. So what are the loopback remote methods? It's actually a way to declare API route on your server. So for example, if I add vehicle remote method to user, it will be accessible from outside by using the URL user/add vehicle. So yeah, remote methods are attached to model, and the syntax is the following. So it's a simplified one. So you have a function here that is your remote method that will be executed once someone queries your server. And once you added this method to your user, to your model, well, you call the remote method function that allows you to declare that this function is a remote method. In our case, there's supposed to be more stuff here, but this is the first step, so it will be covered with the step 14. And yeah, that's it. There's not much, nothing special. Just think that you need to, like the relations, you need to be able to refer to the remote methods separately. Okay, let's get to it. Okay, let's see how I typed these remote methods. So, first thing I wanted to do is solve this error. So let's add the user remote method interface, where I simply mention that there's a function add vehicle, there's a license plate and an age, which is number, and returns void. Yeah, so that should solve. Oh yeah, now that I have this interface, of course I need to say that it goes into the user model. So let's say that user model also extends, the user remote methods, and it should solve this error. Let's run the tests. Okay. Now we simply need to add the remote method utility function that Loopback provides for each model. So we need to add this in our generic model here, Loopback model. So it should be remote method, which is a function that accepts for now a string and returns void. So it should still not work because we are not checking the nature of the string, so we need to have this string among the keys of the user remote method. To do so, well, you need to pass the remote methods of your model. So here we need to pass our remote methods. And once we have them, let's take only the keys of our remote methods. Now, if we run the test, we'll still have one problem, but yeah, so they are not here anymore. They are somewhere else, and it's simple. It's because I added something new to our loopback model, but I did not change all the models. So simple thing to do is just provide a default type value to empty objects, and that should work. Yeah, it does work. There's one last thing I did, but it's kind of overkill. It's more for the anticipation of the step 14. Here, instead of saying directly a key of t remote methods, I declared t remote method key, which extends key of t remote methods. Oops. And I use this instead of this t remote methods key. Yeah, and it's equivalent for now. But it will prove itself. It will prove it. It will be useful in the next step. Okay, so let's talk about the next and final step. So we have dump remote methods, but what we really want is like remote methods with parameters. So our remote methods can. So as I said, it accepts a license plate, which is a string, an age, which is a number. So in terms of our API, that like the API we expose, it's the body of our request, which will be parsed by Loopback and given back as parameters to our remote method. So how do we declare this to Loopback that it accepts these two parameters in the body of the post request? Well, we need the second argument, which is an object. This whole thing. This object has the following shape. So this is quite simple. This is quite simple. But the most interesting part is here. Here we declare the arguments and the types of our remote methods. And to do so, we are using string literals. This has nothing to do with TypeScript, it's pure JavaScript. And we say that this argument is of type string, quote string, and this one quote number. So the interesting thing here is how we are going to achieve converting these string literals to a type. So you can give it a try. I will come back with the solution in a few seconds, as always. So good luck. Okay, welcome to the last step of the workshop. So how could we type these remote method parameters? So first, let's start by doing something dump. Let's add the parameters like this. Let's leave some any types because it's not interesting for now. So the argument is an array, returns any for now. In the array, as you can see, we have this shape arg, which is a string, and type, which is a string. And we have it twice in our case. So let's see what the tests say. Of course, it should fail. Yeah, expected an error, found none. Of course, because we are really 146. Yeah, because there are no constraints at all, so it's normal. So first thing we could do is take this out to a utility type that I will call remote method argument declaration, which is quite dumb for now. It's just this, and we use it twice. Okay, remote method argument declaration. Okay. All right. So there's no constraint on this one for now. So what do we want to do? We want that when we have a type number here for our remote method, we want to have the string literal number corresponding to it. So first thing we need to do to achieve this is get this type, and we'll pass it to our remote method argument declaration and do something out of it. So to get the type, we can use so let's add a generic to it. Okay, whatever. Well, some generic for now. No constraints. Let's name it properly. Parameter type. So how do we get the type of our remote methods? Well, we can use the parameters utility type from TypeScript, which allows you to get the tuple corresponding to the parameters of your the parameters types from your function. So our function in our case is under the remote method key of our remote methods, and the parameter we want to get is the first one. Let's duplicate this, and here we want the second one. So we have an error here. Why? If you have a look, remote methods, I cannot click, sorry. Remote methods of remote method key does not satisfy the constraint that it's not a function actually. That's what TypeScript says. Why isn't it a function? Because here there's no constraint on this, so it could be anything. So actually what we need to do is say that our remote method key, our remote methods are actually an object containing keys and in front of them a function. So args, a function having multiple arguments and returning something. Okay, so now it should not complain anymore because TypeScript knows that this will be a function. Okay, now that we passed the parameter type, we need to do something out of it. We need to extract what literal we should have for each. I cannot simply put parameter type because it wouldn't make sense. This would mean that this would have to be a number, which is not what I want. I really do want this to be a string and exactly the string number. So we can write another utility type. Let's write extract loopback string from type. It takes a parameter type, which should be either string or number for now. And yeah, let's say it's any for now. Does it work? Yeah. No, let's write it completely actually. So if our parameter type, we're going to use conditional types. Let's say that if okay, yeah, format. If this parameter type is of type string, extends string, then it should correspond to the string. If not, then let's check if the parameter type is of type number, and if it is, then it should be a number. If it's not, then we can use the type never. So what does the type never mean in TypeScript? It means that if it exists, then you have a problem. So basically, a variable cannot be of type never, otherwise you will get an error. So if you get in this situation, it means that, well, here you have something else. No, actually, it doesn't mean that. It means that the type is different than string or number. Does it help? Well, I guess it can't be bad. I think it makes sense. Like if you give a symbol, then it returns never, because we don't want a symbol here. So it makes sense. Well, it should not happen, but very often, but it makes sense. Okay, so now we have a utility function that extracts the string out of the type, and now we should just call it extract. So we have a problem here. It says that it does not satisfy the constraint string and number. So let's say here it's string or a number, and I think it should work. It does. It does work. So maybe I won't cover it here, but you can add other types. If you have an object, an array of any, you can add more types here. Object, and here it's object, an array, it's array. Array of any. It doesn't, yeah, it's not really interesting. Same here, I did not complete the types here, but it should be something like verb, post, or get, status, which is number. Here, return type is boolean type, number or string or whatever. But it's not really interesting. One last thing, we handled the case where we have two arguments in our remit method. Well, if we wanted to add more, well, we need to add some overloads as before. So do something like this, and of course this would need some refactoring. But I won't cover it here. I think you got it. Well, that's it for the last step. So I'd like to thank you for following this through. It's been quite a journey. I hope you got something out of it. I mentioned concepts that many people around me don't know, have never heard of. So I hope it's the same for you, and that you can get something out of it. So thank you for listening. Thank you for going through the end. And last thing I'd like to add is that I'd like to thank the TSConf organizers and all the sponsors. It couldn't have happened without them. And of course, I'd like to thank my company, BAM, that really supported me in doing this, which I really appreciate. So that's really, really nice of them. And well, that's it. See you another time, I hope. And have a nice conference.